Let's do some more proofs because you know they're fun. Hopefully these are easier now that we're getting into the triangles. We've already done side, 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 and side, angle, side. Now we're going to look at the difference between angle, side, angle, and angle, angle, side. So angle, side, angle just means that the side needs to be included right here. So if angle A is congruent to angle D, and if AB is congruent to DE, and if angle B is congruent to angle E, then I can make my Big Daddy statement. And I can say triangle ABC is congruent to triangle DEF. And I can do that because of angle, side, angle. So that's what that looks like. So let's walk through some proofs together. All right, so SQ bisects RQT. It bisects RQT and it bisects RST. That's my given statement. Now I can say that RQS is congruent to TQS because of definition of angle bisector. I can also say that RSQ is congruent to TSQ also because of definition of angle bisector. I know looking at this diagram that QS is congruent to QS. I didn't need 2 tick marks. I could use 1 if I wanted. But I know that QS is congruent to QS because of the reflexive property. And now I can make my Big Daddy statement that QRS is congruent to triangle QTS because of angle, side, angle. That side is included between those angles. Let's look at number 2. All right. JK is parallel to LM. That's a given statement. KM is parallel to JL. That's a given statement. Actually, I need 2 on there. All right. Now it's saying that JKL is congruent to MLK. Well, if these lines are parallel, cut by a transversal, I can say that these are congruent to each other because of alternating interior angles. I can also say, if I look at JLK and MKL, these guys are, here's my parallel lines cut by my transversal. So now these guys are alternating interior angles. And I know KL is congruent to KLK because of the reflexive property. And now I have angle, side, angle, and angle, side, angle. So I can make my Big Daddy statement, and I can say angle, side, angle as my proof. Let's do one where we have to do it ourselves. All right, so on this one, BAC is congruent to DEC. Angle BAC is congruent to angle DEC. That's given to me. C is the midpoint of AE. That is given to me. Now, because C is the midpoint of AE, I can say that AC is congruent to CE. I can say that AC is congruent to CE because of definition of midpoint. I can also say that BCA is congruent to DCE. Angle BCA is congruent to angle DCE because of vertical angles. Now I have angle, side, angle, and angle, side, angle, allowing me to prove that triangle ABC is congruent to triangle EDC, and that is my Big Daddy statement of angle, side, angle. Voila. Now, let's move to angle, angle, side. Angle, angle, side just means that you have an angle, and a side. So, if angle A is congruent to angle D, and if angle B is congruent to angle E, and if side BC is congruent to side EF, then you have angle, angle, side. Let's take a look, shall we? So here we go. And let's do these on our own. All right, YZ bisects angle WYX. That's given. Angle YWZ is congruent to angle YXZ. So YWZ is congruent to YXZ. That's given to me. I put up here that YZ bisects WYX. And what does that allow me to say? It allows me to make these two marks and say that angle WYZ is congruent to angle XYZ. And that's just definition of angle bisector. Definition of angle bisector. I look at this diagram and I can see that YZ is congruent to YZ, and that's because of the reflexive property. Now I have angle, angle, side, and angle, angle, side, allowing me to make my Big Daddy statement of triangle WYZ is congruent to triangle XYZ, and that is because of angle, angle, side. Okay? All right, let's take a look at a couple more because I know how much you love them. All right, here we have that angle ABC is congruent to angle CED. ABC is congruent to CED. That's given to me. I know that AB is parallel to CE, and that's given to me. Oh no. Oh, I got scared. And I know that C is the midpoint of AD, and that is given to me. So if C is the midpoint of AD, I can say that AC is congruent to CD, and that's because definition of midpoint. I know I'm trying to prove these guys congruent by angle, angle, side. So if these are parallel, cut by transversal, I know that angle A is congruent to ECD. I know that angle BAC is congruent to angle ECD because of corresponding angles. And now I can make my Big Daddy statement of triangle ABC is congruent to triangle CED because angle, angle, side. Voila. All right, number 6. PR bisects angle QRS. That's given to me. I know that angle PSR is congruent to angle PQR, and that's given to me. So if PSR is congruent to PQR, those guys are congruent, that's given to me. PR bisects QRS, meaning it cuts that angle in half. PR is bisecting this angle. So now I can say that angle PRS is congruent to angle PRQ, and that's definition of angle bisector. I know that PR is congruent to PR because of the reflexive property. Now I have angle, angle, side, angle, angle, side, so now I can make my Big Daddy statement saying triangle PSR is congruent to triangle PQR, and that's angle, angle, side. All right, you know, I should have said stop, pause, and see if we're getting the same thing. Hopefully you've done that. So pause it and then check back in, see if we get the same thing. All right, let's see if ours match up. So LG is parallel to JM. LG parallel to JM, given. H is the midpoint of LM. That's given to me. Okay, well, if H is the midpoint of LM, then I can say that LH is congruent to HM, and that's definition of midpoint. Okay, now, because these two are parallel, cut by a transversal, I can say that angle G is congruent to angle J. Alternate interior angles. I can also say two parallel lines cut by transversal that angle L is congruent to angle M. Alternate interior angles. Now I have an angle on the side, an angle and an angle on the side, and now I can make my Big Daddy statement of LGH is congruent to triangle MJH, and that's because of angle, side. We get it? All right. If you have questions, let me know.